There is a range of search techniques and syntax that you can use to make your search highly specific. Our library databases let you search using these techniques. Library catalogues let you use some of them, and Google Scholar and Google use a very limited number of these features and with far less precision than our databases. Despite the fact that our focus is on structured searching, the search process is highly creative and individual. Ask your supervisors and colleagues how they approach things. It's always good to get different ideas and perspectives. Serendipity also plays its own part in the research journey. One of the first steps to consider is brainstorming keywords and phrases. Think of synonyms. What about American, British, Australian, European terminology? When available, use the thesaurus feature in our subject-specific databases. For example, Education Research Complete, Business Source Premier, CINAHL, Medline, and PsycInfo. And we're happy to show an example of that. Sadly, these thesaurus tools aren't available in the multidisciplinary databases like Scopus. Do some initial searching and in the articles you find, look to see what words the authors have used. Check the assigned keywords listed in the article, and also see what subject terms have been assigned in the database record for the article. Talk to your supervisors, colleagues, etc., and indeed anyone who may be interested. Buy them a cup of coffee and brainstorm ideas for search terms. It can sometimes be very useful to get a perspective from a different discipline or from someone unfamiliar with your field. This is an example from the thesaurus tool in EBSCO's Education Research Complete database. Thesauruses, or thesauri, are very useful tools and can help you find recommended and alternate search terms. You can see here that we browsed for the term primary, and it recommends that we use both primary education and elementary education. Different databases have a different layout or presentation. For example, in Medline, rather than use a thesaurus link, you tick a box that says Suggest a subject term. Also look for the scope notes to find out how the headings or terms are used within the context of each individual database. It's also important to remember that each database does things slightly differently. A good thing to do before you start searching is to either open up the help screen on whichever database you are using to see what search tools and strategies are available. I personally print off the help screens from the relevant databases and have them with me as I structure my search strategies. Phrase searching is one of the most common techniques and ensures that the chosen terms are found next to each other. This helps to make your search more efficient. And this feature can be used in basically every database and search engine. What phrases do you commonly use within your own research? Are you using phrase searching already? The truncation symbol replaces the variant endings of a word. It can be very useful, especially for plurals, variant tenses, and spelling variations. Keep in mind that you can easily get extraneous results if you truncate the term too much, as can be seen by the blue text on the screen. The key feature of truncation is that it will save you time. both in thinking of different endings and actually typing each word out. All databases, including Google Scholar and Google, use the truncation facility. However, Web of Science is the only database that uses both left-hand and right-hand truncation. And you can use the asterisk at both the start and the beginning of the stem of a word to get variant terms within your search results. Not all databases offer a wildcard facility. These replace letters within the word using the specified symbol. You need to check the help files in each database to see if this is an option. Scopus, for example, lets you replace a single letter with the question mark or multiple letters using the asterisk symbol. In contrast, EBSCO uses the question mark for single letters, but replacing multiple letters, they use a crosshash or the hash symbol. Are there terms in your own searches where this wildcard facility might be of use? Proximity operators let you determine how close your search terms have to be within a database record. This is a useful tool to help narrow or focus your search results and to hopefully increase the relevance of them. Not all databases allow this function, and once again you need to check the help screens for searching hints and tips to see if it's available and what search commands you need to use. As an example, both Scopus and our EBSCO databases offer this function along with a number of others. Scopus provides some really helpful guidelines. They suggest that when you're wanting to find terms in the same phrase, use 3, 4 or 5 words. To find terms in the same sentence, use 15, or to find terms in the same paragraph, use 50. Also check in the help screens for information about the order of precedence when searching. Which command is dealt with first by the computer? Proximity operators really need to be used with care. It's worth testing such a search and then comparing those results with a search using the same terms but not the proximity operators, just to make sure that you're not missing anything important. How many of you remember Venn diagrams? Boolean logic is a way of letting you combine your search terms to build a search statement. And searching requires all the terms to be present, and it narrows your results. Or searching requires any of the terms to be present in the results, and this always expands or increases your search results. The third operator, the third Boolean operator, is not, and this lets you exclude search terms. Just as an example, gin and tonic gives you a very different drink to gin or tonic. Now you need to be careful about using combinations of and, or, and not in a search string, and you need to understand how the search logic or the algorithm works. Each database nominates an order of preference, and again, the only way to find this out is to check the help files. You may also want to consider using the search fields within the databases. In EBSCO, the default is select a field, which searches for your terms anywhere in the record. You may want to consider using the subject terms or the abstract. If the if the database has a thesaurus, identify relevant subject headings and use those terms or phrases as subject term searches in addition to the same terms or phrases as keywords or anywhere in the record. And you'd combine those search terms with OR. Within Scopus, the default setting is title, abstract and keywords, and this is generally the most useful for a topic search. We generally recommend that you use an advanced search or a multiple line search. This lets you see your search combinations and your search structure more clearly. Put synonyms on the same line, separated with OR. I type and OR in capitals. The database doesn't need it, but it's a visual prompt for me and makes the search terms themselves easier to see. Although in your search we've used a multiple line format to create the search, the database will generally put the search string within the search history at the bottom. You can see it at the bottom of the screen into a single line. And it uses brackets to group the synonyms or search combinations. Google Scholar doesn't offer the same structure with their advanced search. So I find it useful to do my initial searching in our library databases, then copy and paste the search into Google Scholar. Keep in mind, Google Scholar doesn't use proximity searching or wildcards, so the search won't work properly. Using the brackets or parentheses in a search string is called nesting. It was mentioned earlier, but it's important to be aware that different databases use the Boolean operators in different order. Databases usually, but not always, recognize AND as the primary operator and will connect concepts with AND first. However, Scopus processes the OR terms first. Whenever you use a combination of AND and OR operators in a search, enclose the synonyms or the words to be ORed together, put them in parentheses. Yet again, check the help screens in each database to determine their order of precedence searching. Also consider what types of limits or filters you could apply to your search results. These can be useful in narrowing the number of results or focusing your search a little more. And each database will have its own sets of limits or filters. The Search History Facility is a great resource and is available within all our journal databases. Google Scholar doesn't offer this option, alas. The search history documents each step in your search with the results. It also notes what limits or filters you've applied to each search and includes the result numbers. The most recent search is generally at the top of the list, and you can use the Combined Queries box, we're in Scopus at the moment, to connect different search lines. Make sure you include the hash symbol next to the search line number within Scopus when you're combining your results. And just remember that these search results and history are only available in the current session of your browser. If you close down the database, then go in again, you'll have a blank slate. We'll talk about saving your search results and your search history in another section of this presentation. To this point, we've been looking at practical techniques. We also need to step back and look at the framework or structure of the research question itself. We mentioned the PICO and SPIDER frameworks earlier. As well as formulating your research question, these frameworks can really help with structuring your search strategy. The above example uses PICO, and you can see they've used two subject thesauri from CINAHL and Medline, that's the medical medical subject headings, to get extra search terms. This is an example of a search using the SPIDER framework. Here they've used Boolean logic, the ands and ors. They've used truncation and a range of synonyms. They've also used some phrase searches. At the bottom of the screen, they show how the search terms have been combined in a nested search. You'll come across different terms in the documents you read, and you may want to add these to your search terms as you go along. Research is an iterative process, and rarely will you do a single search and not have to tweak or refine it. Once you're basically happy with your searches and the material being retrieved, it's important to try and verify or check the effectiveness of your searches. In your initial browsing, have you already identified a couple of key papers? Or have your supervisors or colleagues given you a couple of important articles? Did these articles come up in your searches? If not, you need to actively search for them. Look to see what keywords or subject terms have been assigned, and see what needs to be tweaked within your search to be able to locate those articles. In our next section, we'll look at some practical examples, some live searching, showing some of the techniques and strategies we've covered in this particular section of the presentation.